Okay, so this is a lesson on looking at spreads of data distributions and being able to describe them using their shape, their spread, and their center. So everyone should have a copy of this warm-up, and go ahead and get started by typing the data into L1 in your calculator. Okay, so if you still need more time to type the data in, pause the video. Okay, so once you get the data typed in, remember we want to go to Stat and then arrow over to Calc and pick number one variable statistics. And if you get this screen, you just keep pressing Enter. Make sure your frequency list is empty and list is list 1, and calculate. And so using this, we are going to arrow down and to get our 5-number summary. There we go. So here we go. We've got a lower extreme, a minimum of 213, a lower quartile of 521, a median of 987, Q3 is 1,104. Homework tonight is page 23. I might be scrolling off that. Upper extreme is 1,540 songs. Okay, so to find the inner quartile range, once I get those 5 numbers, remember I'm going to go and subtract the Q3 minus Q1, and that's going to tell me how spread out. And so that gives me a spread of 583. Now what I'm going to do is I'm going to multiply this number by 1.5, and I'm going to add that number to the lower quartile. Or I'm sorry, I'm going to subtract that number for the lower quartile, and I'm going to add that number to the upper quartile, and anything that is above or below those limits is going to be an outlier. All right, so when I go to my lower quartile, it's 521, and obviously if I take 521 and subtract this, I'm going to get 0. So I'm going to get a negative number, and there are no negative numbers, so I'm just going to put 0. And I have no lower outliers. Now, for the upper one, I'm going to take my upper quartile, and I'm going to add that last number. Oops. And I get 1,978.5. So I'm going to go look at my data. And do I have anything above that? Actually, I do not. There are no outliers in this data set. None. All right. So now to make my box plot, I'm just going to go ahead. I'm going to plot the minimum. These are kind of obviously going to be approximate. There's the minimum. Here is 500, a little past that, Q1. The median is here. Q3 is here, we'll say, and maybe should be a little more over. And the maximum is at a little bit past 1,500. So there's my box plot. Okay, which measure of central tendency best represents the data? Well, I actually didn't write down the mean, so maybe I'm going to go back and go to Stat, Calc, and get those again. And my average, so this is my median, and the average is 8.64. So I'm actually going to go with 8.64 because I don't have any outliers. So I'm going to say the mean, which is 864, because, and I'm not going to round that to 0.2 because they're songs, you have to have a whole number, because there are no outliers. Okay, it says use the data above to create a histogram. So what I'm going to do is this is going to be a little tricky because I can't see the numbers here, is I'm going to make a really fast table. And my table is going to be, we'll go maybe, goes up to 1,500. So maybe we'll go 200 to anything that's in the 200s to $3.99, 400 to $5.99, 600 to $7.99, 800 to $9.99. Maybe I should have made these smaller because I got a lot of categories here. Yeah, let's make these smaller. It's a pain. Go ahead and erase those. Okay, so I'm actually going to use my calculator to help me out. I'm going to go to calculate, and I'm going to sort, or whoops, to edit, and I'm going to sort list 1. You can just look at mine. You don't have to do this because I'm just doing this for time. Okay, so now all my data is sorted, so that makes life a little easier. I'm going to go 0 to 500. That way I can look over here. In my histogram, I'm going to go 0 to 500. So I've got 2 people, 1, 2. Now I'm going to go 500 to 1,000. And I got a lot there. I've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5. So 3, 4, 5. I'm going to go 1,000 to 1,500. So 1, 2, 3, just 3. Come on. And then 1,500 to 2,000. I think there's only one. Just that guy? Yeah. Okay. What percent of people had at least 987 songs on their phone? So when I go and I look at my box plot, 987 is actually the median. So that's the 50% point. So I'm going to say 50% had at least songs because 987 is the median. Okay, so here are the answers to last night's homework. Go ahead and take a look at page 15. And you can go back and look at the video on your own later if you need to look at it more closely. And here is page 16. And again, I will text you out this link and you can look at it later on your own if you need a little more time. Okay. All right, so this is actually called, this lesson is going to be a lesson on looking at the spread of the data. So we have the data and we have the data and a histogram for the number of text messages Rachel sent out in the last 48, or I'm sorry, I should have read the problem. Rachel found out from 24 of her friends. Okay, let's just read this. Rachel was texting and her mom was trying to have a conversation with her. After they had a discussion about what an appropriate amount of text to send each day. Since they could not agree, they decided to collect data on the number of people. They each asked 24 of their friends. Oh, so half of them are Rachel's and half of them are her mom's. I bet you could figure out which ones were her mom's, which ones were Rachel's. All right, so we've got 48 numbers here. Half of them came from Rachel, half of them came from her mom. So when we look at this data in a histogram, I bet you could circle which ones were her mom's and which ones were Rachel's. So we have a histogram and we have a box and whisker plot. Take a look at the difference. What do you notice about the box and whisker plot versus the histogram? Well, for the histogram, I can tell from the histogram, we can tell there are 2 modes. This is because, well, there really aren't 2 modes. There are 2 peaks, we'll say it that way, because one isn't higher than the other. There's also one outlier. Oop. Okay. Let's compare the box plot to the histogram. Describe the pros and cons of each representation. In other words, what information does each representation highlight? So what I want you to do is pause the video, take about 3 minutes, if you can, and fill in anything you can think of about the pro of looking at the box plot versus the pro of looking at the histogram. All right. With the box plot, one of the pros is it shows how spread out all the data is. We also can see that there is any gaps. We don't see those with the box and whisker plot, so, oh, whoops, that's the wrong spot. Man, I'm having a problem this afternoon. So that's a con of a box plot, is that we can't see gaps in the data. One of the pros of the box plot is we can see where the data is clustered. I don't really know about the histogram. I guess you really can't see specific data points, but you can't see that for the box plot either. Let's go ahead and move on to page 17, or page 18. So, Rachel made a box plot with just the data she collected. And so, what we want to do is we want to describe what she has. What this tells us is that a lot of kids were clustered in the middle, and there were a lot of outliers. At the bottom, and I would even call this B-O-T-T-E-M, U-M, why can I not spell? There we go. And there is one very high outlier at the top. All right. Based on the data, what do you think is a reasonable number to send? So I would honestly just go with the median, because that would be the middle number. There's a lot of outliers here, so we should probably use the median. So here's the important part here. Shapes and spreads. We have a couple of different distributions. I want you to take a look. The normal distribution is like a bell curve. It looks like it goes up and it comes down and it's symmetrical. Now here's where kids get messed up. Skewed right and skewed left. If something is skewed right, that means the right side is empty. And if we say something is skewed left, that actually means the left side is empty. And I know it really seems like it should go the other way around, but it's not. So please make sure you are writing down. If something is skewed right, that means the right side is empty. If something is... That was not the real bell. Don't pack up. Okay, so if something is skewed right, the right side is empty. If something is skewed left, that means the left side is empty. So let's go take a look at some situations with outliers. When we look at a dot plot, it's really easy to see the outlier. It's out there. Same thing with a histogram. Same thing with a box and whisker plot. That's easy to see. The spread of the data, so the shape, we could be normal, skewed right, skewed left. The spread of the data is going to show the variability. And variability is like the range. and the inner quartile range. It's going to show whether there was like consistency or there was no consistency. So for example, someone who had a big spread in their grades maybe has test grades A, B, C, D, and E, and someone with low variability, with a low spread, they mostly get like B's and C's. That would be a low variability. So I know it's hard to read this, but it says which class had greater variability in their data. Class 1 has from 55 to, I think that's 95. Yeah, and then this is 55, and then this is 95. I noticed that class 1 has a lot of people in the middle and only a couple people on each side. So who has greater variability? Class 2. They have no, how do I want to say this? Dominant frequency I mean, if you look at class 1, a lot of people got C's, and you had a couple people with A's and B's, even though they have the same max and min. Class 1 has more people in the middle. And so for who has less variability, that's going to be...
Talk to Masha. Tim, please report to the...
Okay, so which class had less variability? That's going to be class 1, because they had a lot of people in the middle. All right. The center. So the mean is the mean. We know what the mean is. If something is normally distributed, everybody write this down. If something is normally distributed, that means that the mean equals the median. Now, if something is skewed, the mean follows the higher point. Let's say, not higher points, the higher bars. So let's go back and look at those really quick. Let's go back and look at, everyone turn back to page 18 and take a look at these shapes. And let's kind of fill some stuff in. So on a normal distribution, on the one that looks like a bell curve, when we go to look at the center of this shape is still going to be right in the center. This is going to be the mean and the median. And we found this to be true a couple days ago when we looked at mean and median, and if everything was spaced evenly, that the mean equaled the median, okay? Now, for this one, maybe the median falls somewhere over here. Not exactly in the middle because there's more data points over here. So this is our median. But what's going to happen, we can tell that this is the mode, like that's obvious because it's the highest point. The mean is actually going to be, let me switch colors, on this side because we have outliers that are bringing it down. So over here again, obviously this is the mode, it's the highest. The median would be somewhere here. And the mean will be affected by these outliers. So make sure you have that in your picture so that you can talk about the center properly based on the shape. All right. So we've got center, shape, and spread. So what we're going to do is on page 20, we have two graphs, and we're going to talk about the shape, the center, and the spread. When we look at this is the average number of texts per day between Rachel and her mother. Although it got cut off, there's that one little outlier dude over here. The shape of this, so where are we missing data? We're missing it over here on the right. So we say that the shape is skewed right because there's an outlier on that end. The center, we're going to say that the center, because it's skewed right, so that means here's the median is over here, and the average, the mean will probably be somewhere over here on the right. Maybe that's why it's called skewed right, because the mean is skewed to the right. Oh, maybe we're going to say the median is lower than the mean. And the spread, well, let's take a look. We have a lot of gaps. It's not all clustered together. We're going to say that there is high variability because there are lots of gaps. Let's take a look at just Rachel's friend. Rachel's, I noticed the graph is very condensed with a lot of outliers. So the shape, I don't really know that it's specifically skewed one way or the other. I'm going to say the graph is condensed because everything's really tight and skinny. But there are lots of outliers. I want to point out you don't always have to pick like normal or skewed right or skewed left. The shape is really talking about what you see. I see really skinny bars here. So that tells me it's condensed. I see lots of dots. That tells me there are lots of outliers. So the center, because it's so condensed, even though there are outliers, I would bet that the mean and the median are similar for two reasons. The first reason is that it's very condensed. Even though there are outliers, we have upper outliers and we have lower outliers. Okay, so for the spread, I see a big gap here. I see lots of space between these outliers and the box and whisker. So I would say there is high variability. This data is very spread out. Data has a high spread because of large gaps. All right. So on page 21, you've got 6 graphs. So what I want you to start by doing is just looking at these 6 graphs, and I want you to state if they have a skew, if they look normal, and I want you just give each one like one really quick word. Pause the video and go. All right, Smith's class kind of looks like it's skewed right. Lemon's class looks like it's pretty even. Maybe with, not much going on there. All the bars look pretty much the same, the dot plot. But we do have a gap, some gaps. Or one gap, really, just that one right there between, looks like 73 and 80. Data set number 3, Croft's class, I noticed that it's pretty normal and even, except for you've got one outlier. Now, Adam's class, I'm noticing he really doesn't have any E's. So his data is skewed left. All right, now Hurl's class, her data looks very even and normal. And then Jones's class also looks skewed left, but there's an outlier. All right, right, and what I would like you to do is turn the page, and on page 22, you're asked to compare one
Mr. James, can I see your name?
is on page 22, you're going to compare these distributions. Now, this is not easy, so what I'm going to do is I'm going to have you pause the video and go ahead and work on it, and then unpause the video and compare your answers to what I have. All right, so here's the top. All right, and homework tonight is page 23. Go ahead and get started on that right now.